Hello, geometry classes. Let's go over our 11.6 samples, preparing for 11.6 quiz, where we are finding the volumes of prisms. So remember, prisms are three-dimensional solid figures that have the same base on the top, bottom, or on either side of the figure, that those bases are congruent. So we can use that to our advantage when we're finding the volume of these prisms. So our first prism to find a volume of is a cylinder. And cylinder is the mathematical name that we use to describe a circular prism, since there is a circular base on the top and the bottom of this figure. The volume of any prism will be found by multiplying the area of the base times the height, and the height will always be the distance between the two bases. So for this particular solid, this cylinder, the volume will be pi r squared times h, since the base is a circle and the area of a circle is pi r squared. We are given the diameter of 8 inches. We'll need to cut that diameter in half, or divide 8 by 2 to find the radius is 4 inches, and we see the height is 17 inches. So plugging that all into our formula, volume is pi times 4 squared times 17. Our 4 squared multiplied out is 16. So the volume will be pi times 16 times 17, and this would be a good time to plug all that into your calculator. I would do the simplifying first. That can be done to just make it easier to plug it into your calculator. There's less chance for error when you have fewer numbers to plug in. On your calculator, when you plug in pi times 16 times 17, you should see 854.5132, and it goes on from there. Rounding off to the nearest hundredth, the volume would be 854.51 inches cubed. And remember, I am using 3.14 for the value of pi, not my pi button, since not all of your calculators have that pi button. That way we can be consistent with the values we're getting. All right, sample 2. Find the volume of the trapezoidal prism. So we see a trapezoid as a base on the top and the bottom of this figure, and all the space captured in between those trapezoids creates the trapezoidal prism. So we're going to find the volume the same way we found on the last problem. We're going to use base times height. The area of the base of a trapezoid. Okay, so what would be the formula for the area of a trapezoid to fill in our big B, our base? Well, the area of a trapezoid is 1/2 times base 1 plus base 2 times the height of the trapezoid. That's, I'm designating with a little h, times h for the distance between those two bases. So I'm distinguishing between little h, the height of the trapezoid, and big H, which is the distance between the bases. Plugging in my numbers, I would have volume is equal to 1/2 times 5 plus 7. Those are my bases. You can either add 5 plus 7 or 7 plus 5. It doesn't matter what order you add those in, because the commutative property of addition tells you that you'll get the same result no matter which way you add any two numbers. My little h is 2. That is the distance between the bases on the trapezoid. And then times 10, which is the big H. That is the distance between the two bases. Simplifying, I will have volume equals 1/2 times 12 times 2 times 10. Half of 12 is 6. 2 times 10 is 20. So volume is 6 times 20, and 6 times 20 is exactly 120 inches cubed. No rounding necessary on this one. Sample 3, find the volume of the triangular prism. Same formula. Volume is the base, the area of the base, times the height. The triangles that are the bases on this triangular prism happen to be right triangles, so we can use the legs of that right triangle for the base and the height. So volume is equal to 1/2 times base times little h, that's the height of the triangle, times big H, that is the distance between the bases. Plugging in those numbers, we will have volume equals 1/2 times 3 times 4 times 17. And then I'm going to simplify from there. 3 times 4 is 12. 1/2 times 12 times 17 is the result. Since half of 12 is 6, I'll have volume is 6 times 17, and multiplying out 6 times 17, I get exactly 102 inches cubed. Again, no rounding will be necessary for this problem. Sample 4, our last sample, we're going to find the volume of the oblique cylinder. So this is a cylinder that's been tipped on its side, but all the cross sections are congruent to a cylinder that it would be standing straight up, or a right cylinder, so therefore we can still use the same formula. Volume is equal to base times height. The base, of course, will be pi r squared, because we have circular bases, and the height will be the distance between those bases. That is the perpendicular distance between them, and that's been labeled as 8 yards. Remember that if we're given the diameter, we must cut that in half to find the radius. In this case, the radius then will be half of 4, or 2. Our formula does call for the radius, so we need to make sure that if we're given the diameter that we do convert that diameter into the radius before we plug into the formula. Volume is equal to then pi times 2 squared for the radius squared times 8, and that 8 is the height, the distance between the bases. That simplifies to V is equal to pi times 32, and using the value of 3.14 for pi, we plug that into our calculator and we'll have volume is equal to 100.48 yards cubed. Well, that completes our samples for this lesson. It's time for you to move into the quiz for this lesson, and we will see you next time.